Hello everyone, this is the third lesson of Chapter 1, Factors, GCF and LCM. In this lesson, we will be discussing several vocabs. The first one is a multiple. A multiple is a number that can be divided by another number exactly. There should be no remainder, which means I'm not talking about any decimals at this point. For example, if I want to find a multiple of 4, there's 4 times 1, which is 4. 4 times 2 is 8. 4 times 3 is 12, and so on. So in this case, I could say any of these following numbers are multiple of 4. Here's how it's written. 12 is multiple of 4 because 12, I could use 4 times 3 to get 12. The second vocab that you will use a lot in this chapter is factor. A factor is a number that divides exactly into another number. So I know the relationship between multiple and factor could be confusing, but you could also think about it as they are opposite or they are inverse to each other, just like plus and minus. So for example, remember how we were talking about multiples of 4? I could also say the 12 has factors of, if I have 1 times 12, that makes 12. 2 times 6, I can make 12. 3 times 4, I can make also 12. So all of these following numbers are factors of 12, the numbers that I could use to multiply to get 12. This is how it's written. 4 is a factor of 12 because if you're looking over here, the 12 has factors of all these and one of them is containing 4. The third vocab of this page, a prime. A prime is like a factor, except a prime is a little bit special. Prime has only 2 factors, 1 and itself. So going back to this 12, remember 12 has all these followings as the factors. However, if you're thinking about 3, 3 has factors of only 1 and 3. There are no other numbers that when you multiply you get 3. And remember, we're not talking about any decimals in this case. What else? If you're thinking about 17, 17 is a prime number because 17 has only 1 and 17 as the factor. Here's not example. 99 is not a prime because if you are thinking about it, there's 1 in 99, but also I could have 3 times 33. Once you know that there are more than 1 in itself as a factor, it's not a prime. Let's invest an algorithm of the numbers in between 1 and 100. Just to let you know, the 1 is not going to be a prime. The reason it doesn't have 1 is because 1 cannot be a prime number in this case. So we'll start with a 2. They're saying you will need 4 colors, which I have prepared for you. And the first question is, the first number in the list is 2, but do not highlight the 2. Highlight every second number in the grid after 2. So another word, all the multiples of 2. So except the 2, I'm starting with the 4, 6, 8, something like this. Then it's saying number 2. At this point, the lowest number not yet highlighted is 3. Do not highlight the 3, but highlight every third number in the grid after 3. So in other words, we will be using this yellow color to find all the multiples of 3. So except the 3, I'm going to find all the multiples of 3. So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, and so on. Just like this. And double check if I made any mistake because that happens sometimes. Then number 3, the next lowest number not yet highlighted is 5. So highlight all the multiples of 5. We'll use the green. So not 5, but all the multiples. So start with the 10, 15. There's some overlap, which is fine for now, and I'll explain why we're doing this. But let's just follow the instruction really quick. Well, hold on. It's like all these. Number 4, now the next lowest number not yet highlighted is 7. So highlight all the multiples of 7. We'll use blue this time. So I see 6 is highlighted, so except the 7, all the multiples. So 14, 21. Okay, all the blue ones are multiple of 7. Then take a look at all the numbers that are not highlighted. Describe the pattern of these numbers. What kind of numbers are they? So I notice there are 2, 3, 5, 7, and then goes to 11, 13, 17, 19, 23, 29, 31, and so on. Have you found any patterns of all these numbers that I haven't yet highlighted? If you haven't yet, think about why did I highlight such numbers with using different colors. So for example, the 4, I highlighted this number because it was multiple of 2. I highlighted 6 with both orange and yellow because 6 can be multiples of 2, but also can be 3. But think about 41. Was 41 any multiple of what we discussed before? So 2, 3, 5, 7. The answer is no. So the reason we are doing this is because we want to find the prime numbers. If you remember, prime numbers has a factor of 1 and itself only. These are the numbers, if I haven't highlighted it, these are the numbers that you can identify as primes. One of the biggest main concept of a factor is what we call greatest common factor. You probably have heard GCF. This is simply saying your biggest common divisible number. So for example, if I want to find the GCF of 12 and 18, there are two main different ways, but first let's find out what would be the factors of 12. 12 I could divide by, and remember you cannot use any decimals. I could use 1 and 12. I could use 2, 6. What's another one? I could also use 3 times 4 to get 12. So 1, 2, 3, 4, 6, 12s are factors of 12. You're going to repeat the same step for 18. 18 has 1 and 18. 2 times 9, I will get 18. 3 times 6, I will get also 18. Is there anything else? So for example, can I divide this number by 4? No. How about 5? No. And that's it. So 1, 2, 3, 6, 9, 18 are the factors of 18. Then you're going to find what are the factors of these two numbers. In this case, 1, obviously, they both have it. 2, 3. 12 has 4, 18 doesn't, so skip that. And then you have 6. And it looks like they have nothing else in common. Now, among all these common factors, you're finding the biggest number. Which one is the biggest number? In this case, your biggest number is 6. So that's why they were describing in here. The 12 and 18 have 1, 2, 3, and 6 as common factors. However, among all these common factors, the greatest number is 6. What if I give you one more number? What if I am repeating this with another one, 36? So keep in mind that as your number gets bigger, you will have more possibilities of factors. So in this case, 1 and 36. I'm going to have more spaces just in case. I should have 2 and 18. Can I divide this one by 3? Yes. 3 and 12. How about 4? And 9. Anything else in between? 5? No. 6? 6 times 6, I still get 36. So let's try one more time. In this time, I'm going to find the greatest common factor of all three numbers. So I know that 1, 2, 3, they all have in common. 4, the problem is the 12 and 36 has 4, but 18 doesn't, so you cannot count them. Then I have 6. It looks like the rest of them, only 2 numbers or only 1 number has it. So my still biggest divisible number is 6. Here's another way. What if I was asking you to find for 100? This is going to be too much of work to find all the multiples. So the second example we're going to use is what we call ladder method. This is very similar to how you divide, because when I write this, I'm going to list all of them, 12, 18, and 36, like this. Remember when you were dividing, so for example, let's say you're doing 12 divided by 4. You draw this little divider sign. Now, what you're going to do, you're putting it backward, just like this. And you're going to think about what number can I divide for all of them. The first one is probably 1. 1, you can divide for any number. The problem is if you put 1 divided by 12, you get 12. 18, and 36. You can repeat this forever in your life, or we could skip the 1 and think about the next number. I realize that 12, 18, and 36, they are all even numbers, so can I divide by 2? 2 divided by 12, I get 6. 2 divided by 18, I get 9. So just like this, when you are dividing, you were putting your quotient on the top. So 4 goes 12 3 times, and then you get 0. Your quotient comes on the bottom in this case. So that's the only difference. And then the last one, 2 divided by 36, I get 18. Let's think one more time. I believe there is a number that I could divide for all 3 numbers. They are all multiple of 3. So 3 goes to 6 2 times. 3 goes to 9 3 times. 3 times what would get 18? The answer is 6. Now, are there anything else? No more, because remember that the reason we were learning the prime is that the prime could be only one and itself. You already have 2 prime numbers, the 2 and 3. Since I know that I cannot divide anything else, I'm going to stop right here and find the GCF. The GCF is located on your left side. What you're going to do, you're going to multiply all the numbers that you see on the left. So in this case, you're going to multiply 2 times 3, and I get 6. This method works for any number, and we will do more practice on this. Practice 5, number 1, find the GCF of each set of numbers. Make sure your chosen method is clear. Part A, it's up to you how you want to do it. I could list them, so 24 and 36, to find the greatest common factor. So let's see, 24 has factors of 1 times 24, 2 times 12, 3 times 8, then 4, I could do one more with the 6, and 5, there's nothing else. So these are the factors of 24. 36, again, I can always multiply by 1. So 1 times 36, you will get 36. 2, 18. 3, 12. 4, 9. One more, 6. Because 6 times 6, I get 36. You don't have to repeat the same number twice. Now, among here, we'll find the common factors. So they have 1, 2, 3, 4, 6, 12. Anything else? So I know among all these common factors, the biggest number is 12. Let's see if it would work if I had the ladder method. So 24 and 36. If I'm looking at these two numbers, they are both multiple of. You can start with the 2, 4, 6, whichever works for you. I normally start with the smallest number. So I know 1 cannot go in here. So let's start with the 2. 2 goes to 24, 12 times. 2 goes to 36, 18 times. Now I could still do 2. So 2 goes to 12, 6 times. 2 goes to 18, 9 times. Uh-oh, I'm getting out of space. So if I put 3, 3 goes to 6, 2 times. 3 goes to 9, 3 times. Do you remember how to find the GCF on the ladder method? We were looking at it on the left side. So all the numbers on the left, these are the GCF if you multiply them. So 2 times 2 times 3 is, 2 times 2 is 4, 4 times 3, I should get 12, which is the exact same number as what you began with. Let's try part C, 54 and 81. This time we'll do the ladder method. Can I divide both numbers by 2? The answer is no, since this is even. However, this is the odd number. So how about 3? 3 goes to 54 how many times? It goes 18 times. And then 3 times what would get you 81? Or you can do 3. You can do 81 divided by 3. I get 27. It looks like they're both multiple of 9. So you can do 9 if you want. You can do 3 still. It shouldn't matter, but this time let's try 9. 9 goes to 18 2 times. 9 goes to 27 3 times. these are the prime numbers. So you know that you have to stop right here. And I'm only looking at which side? The numbers on the left. So the numbers on the left, I have 3 times 9. 3 times 9 is equal to 27. So I know my greatest common factor of this number will be 27. What if I had 3 numbers? Let's try with the E. If I had E, 21, 35, and 56. You have to think about what number can I divide for all 3 numbers. So in this case, they all look like they're multiple of not 3 because of 35, not 5 because none of the other 2 numbers doesn't work. How about 7? 7 goes to 21 3 times. 35 divided by 7, 5. 56. 7 times what would get you 56? 8. I already know 3 is prime number, 5 is a prime number. 8, you could have factors, but since these 2 are primes, you stop right here. So my greatest common factor is going to be 7. This is another way to check. Remember, you could list them. If you list them, these are the factors of 21, 35, and 56. I'm trying to do fast forward so we could just get the idea of it. You have all the ones, obviously, and then it looks like you have 7s, but that's it. So that's how I know among 1 and 7, the biggest number is 7. So my answer is proved. You want to do one more? Let's try big number. Let's try G. If I had G, 168, 252, and then 240. Since these are considered as big numbers in this case, we are going to try with a little bit bigger factor numbers. So instead of 2, what are they multiples of? Okay, I can do 4. So 4, 42. 4 goes to 252. How many times? 63 times. And then 4 goes to 240. 60 times. Okay. It looks like they're not multiple of 2. Multiple of 3. Oh, 3 works. So if I divide by 3, 3 goes to 14 times. 3 goes to 21 times. 3 goes to 20 times. Can I still keep going? They're not prime numbers, but do they have anything in common? Okay, so that's how I know I have to stop right here. Then again, you're only looking at the left numbers, so 4 and 3. What operation are you supposed to do in between them? I will be doing 4 times 3, which I get 12. The rest of practices, you can do it on your own if you'd like. The second factor concept, we will be using now lowest common multiple. So this time we're going to talk about the smallest common multiples. So we talked about the relationship between factors and multiples, that they could be a little bit opposite to each other, I would say. As with factors, different numbers will have common multiples. We are often interested in the lowest common multiple because this concept will be very useful if you are learning the fraction later. So using the same method, let's find the LCM, the least common multiple of number 4, 8, and 10. So 1, we're going to list all the multiples. The multiples are like when you're multiplying this number by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 times 1, I get 4. 4 times 2, 8. 4 times 3, 12, 16, 20, 24, up to 44. Let's just stop there for a second. And then if I had 8, 8 times 1, 8, 8 times 2, 16. Do you see that they already having some common numbers? But I'm going to just continue and you will see why shortly. Then it becomes 24, 32, 40, and 48. Since I stopped at 44 for earlier number, let me stop in here just for now and let's see if I need to continue more later. 10 is 10 times 1, 10. 20, oh, this one's easy, 30, 40, 50, and so on. Okay, the reason we're going to find the smallest common multiple is because you could do this for all days. However, we don't have that time. So we're just going to find the smallest number that they have in common. It looks like, well, they both have 8, but this one doesn't. So skip that. And 16, okay, doesn't work. 20, 20 and 20 in here, but 8 doesn't have 20. And then if I continue, it looks like they have all 40s together. You would realize if you continue this, you would have had 80, 80, and then 80 over here. However, I'm looking for the smallest number, so you don't need to do any of these. I'm just going to start right here and saying my least common multiple of these numbers is 40. Let's see if that works for the ladder method. If you remember this from the GCF, if I had 4, 8, 10, remember you draw the ladder, we will find still what is their common factor. I could divide all these numbers by 2. So start with the smallest number if you cannot think of. 2 goes to 4 2 times, 4 times, and then 5 times. Now the only difference between GCF and LCM, GCF we had to consider all 3 numbers, correct? However, when we're talking about the LCM, it's okay as long as it satisfies 2 of the numbers. So for example, I could divide this one more because 2 and 4, they're multiples of 2. So if I do so, you get 1 in here, you get 2 in here. But the problem is, can you divide 5 by 2? No, because I said that there should be no decimal in here. So what we're going to do, we don't divide. Since you already used 2 for this, you bring it down. Now that once you have all the prime numbers and there are no more numbers you can divide, you stop. Remember that when we were talking about the GCF, we are looking at the left side, and I told you to multiply them. In this case, you are going to do L shape, just like how you write LCM, and multiply every single number that is under this pink line. So in this case, you're going to do 2 times 2 times 1 times 2 times 5. So 2 times 2, I get 4. 4 times 1 is 4. 4 times 2, I get 8. So 8 times 5, you would realize I get 40. So let me tell you one more time. I know that it could be confusing, the difference between GCF and LCM. However, when you're using LCM in ladder method, you could divide if there are 2 numbers that satisfy to find the factor. The GCF has to satisfy all 3 numbers. Let's do examples. Number 1. Find the LCM of each set of numbers. First, part A, if you had 4 and 6, you could list them, but I think you probably found out now that ladder method could be a little bit quicker so that you don't have to list every single possible numbers. If I divide by 2, 2 goes to 4 2 times. 6 divided by 2, 3. You see these are all the prime numbers, then you stop. The L shape is like this, L shape. So you're going to multiply 2 times 2 times 3. The inside numbers doesn't matter. You're only looking at the outside numbers. So 2 times 2 is 4. 4 times 3, I get 12. Let me show you. If I list them, 4 has multiples of 4, 8, 12, 16, and so on. 6 has multiples of 6, 12, 18, and so on. You found out that there are already common number. And remember, we're finding the smallest. The least number is 12, and that match with what we found using ladder method. Let's try D. The D is 24 and 32. These numbers have multiples of 2 to begin with, so I could do 12 and I could do 16. You can do 2 one more time, you can do 4. Either way, you should get the same answer. So let me try with the 4 this time. So 4 goes to 12 3 times. 4 goes to 16 4 times. Only difference is probably if you divide it by 2, you would get 6 in here, you would get 8 in here. You just have to do one more time. Then you would realize you get 3 and 4 on the bottom. And remember, you're supposed to multiply them. So 2 times 2, I still get 4. Okay. 3 is a prime number, so we're going to start right here since there are only 2 numbers that you have to consider. You're going to multiply all the L shape. So in this case, 2 times 4 times 3 times 4. 2 times 4, I get 8. 8 times 3, I get 24. 24 times 4, I get 96. Imagine that you had to find all the multiples of this up to 96. That could take a while. So if it's up to you, whichever method that works for you works for me, as long as you get it correct. 96. And remember, the three numbers could be a little bit confusing, so let's do G. G is 16, 20, and 80. It looks like they're all multiples of 4. So 4 goes to 16, 4 times. 4 goes to 20, 5 times. 4 goes to 80, 20 times. Earlier, we said if you have a prime number, you stop. But the problem is this is a LCM problem, LCM type. So I could do one more time as long as there are two numbers I could divide by. 4 and 20 you could divide by 4. Or you can do 5 and 20. So if you're choosing 5 and 20, you will be dividing by 5. Okay, so that's up to you. You can try either way, and let's see if we both have the same answer. I'm going to stick with the 4. 4 goes to 4, 1 times. 4 doesn't go to 5, so you keep it there. 4 goes to 20, 5 times. Oh, there's one more number that you can do. Remember, as long as there are two numbers that you could divide by, you just keep going. So I'm going to do now 5. This one doesn't change since you cannot divide them. 5 goes to 5, 1 times, and that's what I get. Now you multiply them, L shape, so you'd realize you have 4 times 4 times 5 times 1, which is just ones. So 4 times 4, I get 16. 16 times 5, I get 80. 80 times 1, I should get 80. So they're saying that 80 is the smallest common multiple of all three numbers. This is the end of the practice where I'm just going to leave these for you to practice on your own. And if you have any questions, please leave a comment. But before I end the class, today I brought the activity. I thought this would be fun puzzles for you. So what you're going to do is you're going to read through the set of clues to determine the mystery number in each case. So if you want to do this, you can guess a number with me. Otherwise, you could stop and you could watch another lesson. Part A, what number am I? I am a number between 40 and 70. I am a prime number. My digits add up to 8. You could pause here before I give you a hint. If you couldn't figure out yet, here's a hint. Remember that they were saying the number has to be between 40 and 70. So I know it's a 2-digit number. And the last example, they're saying my digits adds up to 8. So when you add these two numbers, your 2-digit number, it has to be 8. That's what it's talking about. If you do not remember the prime numbers in between 40 and 80 are over here, in between 40 and 80. The answer is 53. Kudos to you if you got it correct. If you didn't get it, I will give you another chance. Here's part B. What number am I? I'm a 4-digit number. My hundreds digit is 8. The difference between my hundreds digit and ones digit is 1. So when I'm subtracting between this number and that number, it has to be 1. I don't know which number will be bigger. So there are few possibilities. My thousands digit is 1/4 of my hundreds digit. So 1/4 is 1/4. Then you should know what the hundreds digit is by now. My tens digit is triple that of my thousands digit. So now that you should have a clue of thousands digit, then you triple them. Triple means you multiply by 3. All my digits add up to 23. When you add them all up, it should be 23. You can pause it for now. The answer, so I know that there's 8. And there were a few possibilities, but if you used 8, you knew that my thousands has to be 2. And then you could guess, okay, so this has to be 7, and then this has to be 6, because when I add them all up, it becomes 23. 2 more. What number am I? I am a 3-digit number. I am a multiple of 6. My tens digit is 8 times my hundreds digit. You can pause it here for now. Here's a hint. Remember, there were 3-digit numbers. A multiple of 6, so let me pause it for a second. My tens digit right here is 8 times my hundreds digit. The problem in here is there could be only in between 1 and 9. If you're only multiplying by 8, there are very few numbers that you can put. So for example, I know my tens digit is bigger than my ones digit, so my hundreds digit. There's only one possibility. It has to be 1 and 8. Because if it's more than 1, such as if it's 2, 2 times 8 is already 16. It's over one's digit, so it doesn't work. Then remember, it has to be a multiple of 6, so I know at the end I should have 6. The last example, if you can read it on your own and pause it right now. The answer is 62,843. If you got everything correct, kudos to you. If you didn't, hopefully we will have another chance to practice. This is the end of the lesson. Thanks for learning with me. If you have any questions, please leave a comment.